12.5 part 2. We've done it. We've made it to the final video. So we are going to do some practice with permutations and combinations. So find the number of ways you can arrange all the letters in these words. Now, the ways you can arrange all those letters, that means it's a permutation where order matters. But now keep in mind, a permutation formula, n factorial over n minus r factorial, but I'm arranging all the letters, which means n equals r. So n factorial over n minus r factorial gives me 0 factorial, and what did we say in the last video is that 0 factorial equals 1. So the answer is just n factorial. So who has 3 letters? So n equals 3. So my permutation equals n factorial. 3 times 2 times 1 is 6. Here we have n is 4. 4 factorial, 4 times 3 times 2 times 1 is 24. And here, n is 5. 5 times 4 times 3 times 2 times 1 is 120. So when they're smaller like this, it might just be easier to write them out. Once we get with bigger numbers, we're going to want to use the factorial on our calculator. So 15 sailboats are racing in a regatta. In how many different ways can 3 different sailboats finish first, second, and third? Because we want them to finish first, second, and third, this is going to be a permutation because order matters. So it's n factorial over n minus r factorial. So how many total? There are 15 sailboats in total, so that's my n. They're finishing first, second, and third, so I'm choosing 3. So I have 15 factorial over 12 factorial, or over 15 minus 3 factorial. Now keep in mind that is 15 times 14 times 13 times 12 factorial instead of going all the way back. And that gives me 15 times 14 times 13, which is 2,730. So there are 2,730 different ways that just 15 sailboats could finish the race, which is very interesting to me. Here, you and your friends are ordering a 3-topping pizza. The pizzeria offers 8 different pizza toppings. How many different topping pizzas are possible? Well, in this case, this is going to be a combination. It doesn't matter if you get pineapple and ham or ham and pineapple, or if you're following my personal favorite is pineapple and eggplant. That's my personal favorite pizza, don't judge me. How many different pizza toppings are possible? Well, that's a combination, which means n factorial over n minus r factorial times r factorial. So there's that extra step with the r factorial. So there's 8 total that I could pick from. I'm choosing 3. So I have 8 factorial over 8 minus 3 factorial, 3 factorial. So that's 8 factorial over 5 factorial, 3 factorial. You cannot combine these. These are separate things. Do not combine them. So that gives me 8 times 7 times 6 times 5 factorial times 3 times 2 times 1. So I didn't expand out the 5s, I kind of left them. So I get left with 8 times 7 times 6 over 3 times 2 times 1, which is 56. So there's 56 different pizzas you could make. Let's do 2 more examples. On a biology lab exam, there are 8 stations available. You must complete the labs at 6 of the stations. How many ways can you complete the exam? Now, it's not saying that you have to, that the order that you do them matters. It's just saying you have to complete 6. So, you must complete 6. The order doesn't matter. So this is a combination. So n factorial over n minus r factorial. So there's 8 stations. That's my n. I'm choosing to do 6 of them. So I have 8 factorial over 8 minus 6 factorial, 6 factorial. Eight factorial over 2 factorial, 6 factorial. 8 times 7 times, I'm going to stop there at 6 factorial. So these can cancel out. The 2 factorial is 2 times 1, so I have 8 times 7 divided by 2 times 1 is 28. And we'll do one more. So your band director is choosing 10 seniors to play the final concert. There are 44 seniors in the band. How many different groups can be made? Well, it's not like we're doing like first chair, second chair, violin. The order doesn't matter, they're just playing. So this is going to be another combination. So how many are there to choose from? Choosing from 44. The group is going to be 10. So this combination is going to be 44 factorial over 44 minus 10 factorial, 10 factorial. That's 44 factorial over 34 factorial. 10 factorial. Now this starts to, the numbers get higher. You might want to use your calculator instead. So we want to make sure if we're putting it in our calculator, you want to make sure you're doing 44 factorial divided by, you want to make sure you're dividing by the whole thing and not just the 34. So we have 44 math, you go over to probability, factorial divided by 34 factorial and 10 factorial. And that's why we want to use our calculators, because sometimes it's going to be very large. So if there are 44 seniors and you're picking 10, even if order doesn't matter, there's still going to be 2, 4, 8, 1, 2, 5, 6, 7, 7, 8. 2,481,256,778 different groups. And that's with order doesn't matter. Imagine if it did matter and you were player 1, player 2, player 3. that's actually the only difference is you're not dividing by the extra r factorial. That's so big a number, it can't even, the calculator can't even see it. If you see that little e, it means to the times 10 to the 15th. So these numbers are going to get really big. That's why we want to make sure we're using our calculators. If you get an e like that, it means it's too big. All right, that was the last video, and you can now do your 12.5 homework, and this is the last section. Congratulations.